Welcome back. Today we are going to look at section 6.5a, solving square root and other radical equations. Our learning targets today are to solve radical equations and to solve equations that have rational exponents. So a radical equation is an equation that has a variable inside the root. To solve them, our first step is to isolate the radical term. Our second step would be to raise both sides to the power of the index. For example, square roots, we would have to square both sides. For cube roots, we would have to cube both sides, etc. Our third step is then to solve the resulting equation for x. And our last step, which is very important, is to check our solution. So go ahead and pause the video for a minute and copy those steps down, and then turn it back on when you are ready. All right, for our first one, our first step is to isolate the radical term. That means that we need to have this part right here all by itself. So the first thing I would want to do is to subtract that 3 to the other side. I now have the square root of 2x minus 3 equaling 5. My next step then is to undo the square root. So to do that, I have to use the opposite index, or the opposite of the index. The index is a 2, so instead of a square root, I'm going to raise both sides to the second power. I'm going to square it to cancel the square root. On the left side, the square and square root undo each other, and we just get the 2x minus 3, the radicand. On the right side, we actually have to take 5 and square it, which gets us 25. From here, we're just solving a linear equation. So we're going to add 3 to the other side, and then we're going to divide out our 2. So we end up with x being 14. To check that, we're going to plug a 14 back into the original problem. So we have 3 plus the square root of 2 times 14 minus 3, and we're supposed to get an 8. So let's clean up the left side of this. Inside our square root, 2 times 14 would be 28, minus the 3 would be 25. The square root of 25 is 5, and 3 plus 5 equals 8. And since we're getting what we were supposed to get, it means that this is a correct solution. All right, for the second one, we are trying to isolate the root piece again. So I'm looking for the cube root of x minus 5 to be by itself. So to undo that, we're going to have to divide both sides by a 4. And we get the cube root of x minus 5 equals 2. Now to undo a cube root, we have to cube both sides. On the left, the cube root goes away. We get x minus 5. On the right, 2 cubed would be 8. Adding the 5 over, we get x equals 13. And now we have to check that. So we're going to plug it into our original equation. So 4 times the cube root of 13 minus 5 is supposed to equal 8. 13 minus 5 is 8. The cube root of 8 is 2, and 4 times 2 does get us an 8. So this is correct. All right. What about an equation when we have 2 radicals? There's one on each side. Notice that they're both square roots, and to undo a square root, we have to square both sides. So on this particular question, both square roots are going to disappear. We get 2x equaling x plus 7. When we square something that was square rooted, cancels that out. Bring our x's to one side, we end up with 1x equaling 7. Again, we have to check it. So the square root of 2 times 7 is supposed to equal the square root of 7 plus 7. We end up with the square root of 14 equaling the square root of 14. So that does work. So x does equal 7. Shifting to solving when we have a rational exponent. Remember that in a rational exponent, the top number is our power and the bottom number is our root. Okay? So we're still looking at radicals. They're just written a different way. So to solve an equation with rational exponents, we need to use the reciprocal power to cancel the current power. And again, make sure that we check our solutions. So for the first one here, we have x to the 3/5 power equaling 8. To undo a 3/5 power, we need to use its reciprocal. Its reciprocal is just the fraction flipped over. So we need a 5/3. And whatever we do to one side, we have to do to the other side. On the left, the 3/5 and the 5/3 are going to undo each other. We end up with 15 divided by 15, which is 1. So we just get x to the first power. On the right side, remember that that bottom number is our root. Top number is our power. So we are really taking the cube root of 8 and then raising it to a 5th power. Well, the cube root of 8 is 2, and 2 to the 5th is 32. Okay, let's check that. So we have 32 to the 3/5 power is supposed to give us an 8. Now with a 3/5 power, we're taking a 5th root of 32 and then cubing it. The 5th root of 32 is 2, and 2 cubed will get us the 8. So it does work. All right, for the second one, we have the quantity x plus 5 to the 1/7. Remember, 1/7 just means we're doing a 7th root. So to undo that, we're going to raise it to the 7/1, or just 7 power. On the left, we get x plus 5. That 1/7 and the 7/1 are going to cancel each other out. On the right side, we get 3 to the 7th, which is 2,187. And now we're going to subtract 5 from both sides. So 2182 is our solution. All right, checking it, we're going to take 2182, we're going to add 5 to it, and then take its 7th root. Adding 5 gets us 2187. And that's supposed to equal 3. When we take the 7th root, we end up with 3. So it does work. All right. Go ahead and pause the video for a minute and look at this next one. See if you can figure out what our first step should be. So remember, when we're solving these radical equations, we need to isolate the root piece. So the first thing we're going to do is we're going to divide out this 2 from both sides. We now have x minus 2 to the 5/3 power equals 32. And then to undo a 5/3 power, we're going to raise it to a 3/5. And whatever we do to one side, we have to do to the other. On the left, it cleans up to just being x minus 2. On the right, we are taking 32. We're going to do its 5th root, and then we're going to cube that answer. The 5th root of 32 is 2. 2 cubed is 8. So x minus 2 equals 8, which means if we add the 2 over, x should be a 10. Again, checking that. We have 2 times 10 minus 2 to the 5/3 power is supposed to equal 64. 10 minus 2 is 8. 8 to the 5/3 means we're cube rooting the 8, which gets us a 2, and raising it to the 5th power, which is 32. And 2 times 32 is 64. So that one worked as well. For the next couple questions, we have to be very careful. It says, remember, when you take an even root, for example, if we're solving x squared equals 49, we always end up with a plus minus. Okay, so we have to be careful if when we're undoing these radicals, we end up with an even root. All right, for our next example, we want to isolate the radical part, which is this. We have to add the 3 to the other side. So x plus 7 to the 2/3 should be 25. To undo a 2/3, we have to raise it to a 3/2 power. So now in this one, we are taking a square root of 25, and we have to consider that that could be a positive or a negative 5. Since there's no square root symbol written, we have to use both. So we've square rooted the 25 to get plus and minus 5. When we cube that, we get plus minus 125. On the left side, the 2/3 power and the 3/2 power undo each other, and we just have x plus 7. So we really have two equations here. X plus 7 could equal negative 125, and x plus 7 could equal positive 125. We actually have to do both of these. Subtracting a 7 to the other side gets us x being negative 132. On the right side, subtracting a 7, we end up with x being 118. All right, we're going to check both of these. So going back to the original problem, it said x, which in this case was 132, plus 7 to the 2/3 minus a 3 is supposed to equal 22. Okay? Negative 132 plus 7 is negative 125. If we cube root it, which is what we have right here, the cube root of negative 125 is negative 5. We then square it, subtract 3, we're supposed to get 22. When we square negative 5, we have 25. So this does appear to be working. All right, checking the second one. We had a value of 118 for x. So 118 plus 7 to the 2/3 minus 3 is supposed to equal 22. Adding the 7, we get 125. Cube rooting 125, we have 5. Squaring that 5 gets us 25. So again, this one is working out fine. So we have two answers, negative 132 and positive 118. All right, for the next one, we have a few things we have to do to unravel this one. The first thing I would do is get rid of that plus 3. We're going to subtract it over. So we have 2 times the quantity x minus 4 to the 3/4 power is equal to 54. Then we're going to divide out the 2 from both sides. So x minus 4 to the 3/4 power equals 27. And now to undo a 3/4 power, we're going to raise both sides to the reciprocal 4/3. The left side simplifies down to just x minus 4. On the right side, we are cube rooting the 27 and then raising that to the 4th power. Remember, your bottom number is your root, top number is your power. The cube root of 27 is 3, and 3 to the 4th is 81. Adding 4 to the other side, we have x being 85. Okay, let's check that. So we have 2 times 85 minus 4 to the 3/4 plus 3 is supposed to equal 57. Okay, 85 minus 4 would be 81. 81, if we 4th root it, is 3, and 3 cubed is 27. So this becomes a 27. 2 times 27 is 54. Adding the 3 gets us the 57 that we were supposed to get. All right, so it is working. We are really practicing that checking step because tomorrow we're going to run into some where they don't work. All right, we just have a couple left to do. For this next one, again, we have several things in the way. we are trying to isolate that root again, so we just want this part. So we have to get rid of the 1 and the 3. We're going to subtract the 1 over. Okay, we're going to divide out the 3. Now, the way it's written, we are taking a 5th root and we are cubing it. So it's really the same as this. We really have a 3/5 power there. We're cubing and we're 5th rooting. And to undo that, we have to use the reciprocal power. So we're going to raise both sides to a 5/3 power. The right side then just becomes x plus 1. On the left side, we are cube rooting the 8 and then raising it to the 5th power. Cube rooting 8 is a 2. 2 to the 5th is 32. So x plus 1 equals 32. When we subtract the 1, we get 31. All right, plugging that back in to check it. 3 times the 5th root of 31 plus 1 cubed plus 1, and we're trying to get a 25. 31 plus 1 is 32. Its 5th root is 2. 2 cubed is 8. 8 times 3 is 24, plus 1 is 25, which is what we're supposed to get. So it is correct. Now, for the last one, we have a quantity to the 1/2 power minus another quantity to the 1/2 equaling 0. We really could have written this as the square root of x plus 1 minus the square root of 2x minus 3 equaling 0. A 1/2 power is the same as a square root. To simplify this, or to solve this, I should say, we really want to get both one on each side. So I'm going to add this square root of 2x minus 3 to the other side. So now I have the square root of x plus 1 has to equal the square root of 2x minus 3. And now to undo a square root, we are simply squaring both sides. Squaring this gets us x plus 1. Squaring the right side, we get 2x minus 3. Getting x's to one side and getting the x by itself, we're going to add 3 to the other side. So we end up with x equaling 4. All right, let's check that. We're going to put a 4 in for both of our x's. We have 4 plus 1 would be 5 to the 1/2 power. For the next chunk, we have 2 times 4, that's 8. Minus 3 is 5. And 5 to the 1/2 minus 5 to the 1/2 does get us 0. All right, so it did work. All right, our last example, it says for this meteor crater in Arizona, the formula D equals 2 times the cube root of the quantity V divided by 0.3 relates the diameter D of the rim in meters to the volume V in cubic meters. What is the volume of this crater? I do want you to notice that we are given the diameter in kilometers instead of meters. But in our formula, it says we are supposed to have meters. So we need to do a conversion here. 1.2 kilometers is the same as 1,200 meters. Okay, there's 1,000 meters in a kilometer, so times by 1,000 we get 1,200. Now we can plug that into our formula. So we put that in for diameter. 1,200 equals 2 times the cube root of V divided by 3/10. First thing I would do is divide that 2 over, so we end up with 600 equals the cube root of this quantity. And then to undo a cube root, we're going to cube both sides. Cubing 600, we cube the 6 and get 216. We cube those zeros and we end up with 3 sets of 2 zeros. On the right side, cubing cancels the cube root, and we get v divided by 0.3. So to solve for v, we're going to multiply both sides by 0.3, and we should end up with 64,800,000 cubic meters for the volume. All right. Let me know if you have questions. Send me an email. One last thing. Don't forget that when you are taking an even root, so we have a quantity to say a 2/5 power, when we undo that, we're raising it to a 5/2 power. And right here, we're taking an even root. These are the ones where we need to use that plus minus when we're solving. So we're going to get 2 separate equations to solve. So watch for those particular ones.